Hello, I was asked to do number 17 from 4.1. So number 17 says, the maker of an automobile advertises that it takes 11 seconds to accelerate from 15 kilometers per hour to 80 kilometers per hour. Assuming constant acceleration, compute the following. The acceleration in meters per second per second. So we want to get the acceleration. Well, first we have to do, so they want this in meters per second per second. They want that. That's essentially meters per second squared. We have it in kilometers per hour, so the velocity at time 0, we'll start at 0 index being that the initial velocity, is 15 kilometers per hour. But we want to convert from kilometers to meters, and there are 1,000 meters in 1 kilometer. That allows kilometers to cancel out. And then we want to go from hours to seconds. So there is 1 hour for every 3,600 seconds. And this is called dimensional analysis. I wanted to cancel out kilometers, so I had to put it on the bottom, put its equivalent on top. I want to cancel out hours, so I put it on top, put its equivalent on bottom. And so 15 times 1,000 times 3,600. Let's get the handy dandy calculator out here. Okay, and I get 25 over 6 meters per second. And if I do the velocity at 11 seconds, it takes 11 seconds it says, that's going to be 80 kilometers per hour times, again, 1,000 meters per 1 kilometer times 1 hour over 3,600 seconds. And here I get 200 over 9 meters per second. And a common denominator between 6 and 9 is 18, so we can see these are equivalent to, multiplying that by 3 over 3, 75 eighteenths meters per second. Multiplying this by 2 over 2, I'm going to get 400 eighteenths meters per second. Okay. Be nice to have the same denominator for the next calculation. Now, a of t, that's our acceleration with respect to time, is just a because we have constant acceleration. The velocity at time t is going to be the acceleration times time t plus some constant. And we know the velocity at time 0 is, as we found above, 75 eighteenths, which will be acceleration times 0 plus the constant, which means our constant is going to be 75 over 18. So we also know our velocity at time 11 seconds is 400 eighteenths. That's going to be the acceleration times 11 plus 75 eighteenths. By the way, our velocity equation is going to be a times t plus 75 eighteenths. So what this says is 400 over 18 equals 11a plus 75 over 18. And then we can subtract 75 eighteenths from both sides. And we get 325 over 18 equals 11a. And we can divide both sides by 11. And a, let's go back to blue. A equals 325 divided by 18 divided by 11. And I get 1.641 meters per second squared. So the second part Bam! There it is. Okay. The distance the car travels during the 11 seconds, I'm going to find that. So we use a position function, s of t equals a, or it should be 1/2 at squared, plus v naught t plus s. And in this case, our, I should say s naught 0. And our v naught we know from above was 75/18. So we're talking about this, the position function after 11 seconds is going to be 1/2 times 1.641 times 11 squared plus 75/18 times 11 plus 0. Oh, I forgot my 1/2. Oh, I got the half. Okay. So it's 0.5 times 1.641 times 11 squared plus 75 divided by 18 times 11. And I get S equals 145.114. And there might be some round off because this is a rounded number. I think the answer that the computer wanted for this one is 145.14 meters. So I would take either answer. Okay, I hope that answers the question.